Okay, guys, so let's start the revision for the statistic quiz number 2. For the second quiz, let's do this revision. So before starting a revision, let us remember the empirical rule. When a distribution is bell-shaped, the following statements are true. Approximately 68 of the data values will fall within one standard deviation, and approximately 95 of the data values will fall within the two standard deviation, and 99.7 of the data values will fall within the three standard deviation. So we have to keep this in our mind. Now the question is this: heights of boys on a football team have a bell-shaped distribution. So it's important. With a mean of 180 centimeters. So let us copy down. The mean is 180 centimeter. And standard deviation, which is equal to 4 centimeter. Using the empirical rule, what is the approximate percentage of the boys between 176 and 184 centimeter? Okay, so when we look at these two values, which is 176 and 184, since our mean value is 180, so 180 minus 176. When I check, this is now 4, and 180 plus 1 standard deviation, which is 184, or I can easily say that instead of this, I can say, maybe this is better, so 184 is subtracted from the my mean value, which is 180, so it will be 4. So 4 is 1 standard deviation. So we have mu, let's say here, the mean, and our points are here, which is mu minus 1 standard deviation and mu plus 1 standard deviation. You know, when we have the bell-shaped distribution, so we say that this is the mu, and now this will be as a percentages mu minus 1 sigma, mu plus 1 sigma. What will be, if you remember, it says that 68% of the data. That means this area will be 68% of the data. So the answer of the question, part A, is 68%. What about for the second one? 172 and 188. So my mean value was 180. If I subtract 172, it will be 8. 8 is 2 times standard deviation, since my standard deviation is 4, I know. So what about 188? 188 minus 180, when I subtract, it will be 8. So 8 is 2 times standard deviation. So easily I can say that when my data values are bell-shaped, when the mu is here, which is given 180, so my values are 1 standard deviation here, and then 2 standard deviations are here. It means that all this area we are looking, this is 172, which means mu minus 2 sigma, and this is 188, which means mu plus 2 sigma. And so what are we going to say? We will say that by using the empirical rule, 2 standard deviation when we have 95%, so we will say that is now 95%. So similarly, 168 and 192, for the mean value, which is given 180, when I subtract the left number 168, I will see that 10 minus 8, 2, 7 minus 6, 1, 12, and 12 is divided by standard deviation, which is 4, so it will be 3. That means mu minus 3 standard deviation, I will have 168. So let me check mu plus 3 sigma. So mu is 180, and then my right side or right boundary 192. When I subtract this, 2 and 1, 12. 12 is when I divide by standard deviation, which is number 4. 3 and 4 will be 12. And that means that mu plus 3 sigma is equal to 192. So what can I say? It's easy to say that when I have the distribution bell shape, when mu is here, so all my data values which is being asked to me from 168 to 192, 168 is here, 192 here, and this is mu minus 3 sigma, and this is mu plus 3 sigma. By using the empirical rule, it's easy to say that it will be 99.7. So the percentage will be 99.7%. Okay, now let's go for the second question. One of the tallest living boy has a height of 225 centimeter. One of the tallest living girl, 230 centimeter tall. So for the boy, 225, and for the girl, 230 centimeter. Heights of boy have a mean of 165 centimeter. So if I say that the mean value for the boy, let me put boy, 165, and then the standard deviation is 4. So standard deviation for the boy is 4 centimeter, and the tallest boy, which is my x value, xb, let's say, this is 225, and then it says that one of the tallest living girl 230 centimeter. So I can say that the data value for the girl is 230 centimeter, and then the woman have a mean 150. So the mean of the woman, let's say G for the woman or the girl, let's say 150, and then standard deviation for the girl is equal to 6. So what is the question then? So what is the question then? By the way, this should be girl, not woman. Okay. Now, the question is this. Relative to the population of the same gender, who is the taller? I mean the boy or the girl? Boy or the girl? Which one is taller? Okay, based on the population, relative population. Now to solve this, we have to use the z-score. Z-score for the boy, if remember, xp minus x bar divided by standard deviation for the boy. If I say it will be 225 minus 165 divided by 4, so it will be approximately, now I'm using my calculator, so 225 minus 165 divided by 4, it is approximately, actually not approximately, directly 15. And then if I calculate for the girl, the same thing, it will be 230 minus 150 divided by 6. So let me do this. 230 minus 150 divided by 6 equals approximately 13.3. So when I look at here, the the z-score of boy is greater than the z-score of girl. So I can say that who is the taller? The taller one is the boy, or the tallest one is the boy. Why? Since the z-score is more than the z-score of the girl, or bigger than the girl. Okay, now third question. If your score on your next physics test is converted to a z-score, which of the these z-scores would you prefer, and why? Of course, when the z-score is positive, it means that you are on the right side of the mean. So your score is greater than the mean. So let us remember. So when we have this bell shape, if this is the mu, okay, we can say that for the mu z is equal to here 0, we can say. Now, when you have the 1.20 or 1.2, that means that you are 1.20 standard deviation far away from the mu. That means that your result will be somewhere here. So your score will be greater than all the others. So how far you are from the mean on the right side, that means you have the biggest score. So the answer is, of course, I prefer the 1.20 since I will be 1.20 far away on the right side of the mean. Okay, then the question, another question. According to the given table, what is P62? P62 means we have to find 0.62 or 62 over 100 times overall data. So how many data we have? We have to count after ordering, but it is clear that it is ordered. So 1, 2, 3, 4, 5, 6, 7, 8, 9 here. 1, 2, 3, 4, 5 here. That means 9 times 5. There are 45 data. So for the 45 data members, what will be P62? To calculate this, 0.62 times 45, when we say, it will be approximately 27.9. So we will count where we have this member. So 1, 2, 3, 4, 5, 6, 7, 8, 9 till 27 points. So 9 and another 9, 18, and another 9, 27. After 27, this will be 28 position. 28 position. So since I have after 27, I have to go. So 27 was here. After the 27, I have to go, which is it's here 28. So the answer of the question B62 is 64. That's it. Now the other question. Survey results says that 85% of the student pass. So 85% pass means the fail will be 100% minus 85, right? 100% minus 85%, which will be 15%. Or you can say that 1 minus 0.85, which is 0.15 as a decimal. So what is the question? If I select a student from your class randomly, what could it be probability of that student will fail from his exam? And so we already said that if we have the survey results shows that the probability of the students 85 pass, so not to pass, which means the fail, is equal to 0.15. You know that it comes out this rule, PA plus PA complement is also always 1. I mean, probability of any event plus probability of not to see that event is equal to 1. Okay, now let's see another question here. What we have if one of the 150 test subjects, is randomly selected, what is the probability of getting a subject who is infected? So probability infected. This is our question. So what is the rule of the probability of any event? You know, probability of event A is equal to an A over an S, which means how many times this event is being occurred in your list, and what is the size of the sample space? First of all, size of the sample space means 60 plus 40 plus 20 plus 30, which is 150. It is actually given at the beginning of the question. But you can count also 60 plus 40 plus 20 plus 30. If you get the sum, it will be 150. Now, the important point is here. It says that infected. So when you look at here, this row, okay, horizontally, patient is infected. How many? 60. How many? 20. So it will be 60 plus 20, which will be 8 over 150. When you simplify 8 over 15, and when you use the calculator, the result will be, let's see, 8 over 15, which is equal to 0.53. That's it. So for this table, we are not looking at positive test result infected, negative test results, so not infected. Okay, the test result may say, but in the reality, how many of them are infected? 60. In reality, how many of them are 20? So this is important for me. So I'm looking for the infected one. Okay, so that's the answer. I hope everything is clear. You understood